So there's one more type of permutation question I want to look at, and that's pathways. So to determine the number of pathways from A to B, you can only move down and to the right. And that's kind of the key to this. You're not allowed to double back. So if you really think about how to get from A to B, you're always going to take the same amount of steps. You're always going to end up going 1, 2, 3 down. You're always going 1, 2, 3, 4, 5 to the right, no matter what. Now you could take a path like one right and then one down, one right, one down, one right, one down, and then two more right. But at the end of the day, you're still going 5 right, 3 down. And so then really we have eight possibilities here. So 8 factorial. Now there is some repetition though. And those repetition is the number of ways that we can go down. So here there's 3 down. So it's going to be 3 factorial. There's our repetition. And then our 5 right, well, there's 5 repetition there as well. And so you end up with 8 factorial over 3 factorial times 5 factorial. Put that in your calculator all at once, you get 84. Now B is very similar, but this time we can only move up and to the left. So again, we're going to count how many pathways it would take to possibly get here. So 1, 2, 3, 4, up, and then 1, 2, 3, 4, 5, 6 to the right. Okay, so then we have our 10 possibilities, but we're going to have some repetitions. So that's going to come from how many are up and how many are to the right. So we get 4 factorial up and then 6 to the right factorial. Again, in a calculator all at once, you'll get 210. And so there's 210 different pathways.